Hi, in this topic we will learn about NumPy. NumPy is a Python module that provides fast primitives for multi-dimensional arrays. It's well suited to implement linear algebra algorithms, and for those it can be much faster than Python's native lists and dictionary types, especially when you only need to store and operate on numerical data. To set up, go ahead and run the first code cell. This imports the NumPy package that is required for this lesson. As mentioned earlier, NumPy provides fast primitives for multidimensional arrays. Let's look at how to create an array in NumPy. NumPy.array helps you do that. All it takes is a list of numerical elements. As you can see from above, that it outputs something that looks like a list. Then why even bother with NumPy when we already have Python's native lists and dictionaries to store and operate on numerical data? The answer is simple. It is quite faster to perform operations on NumPy arrays. Let's look at an example. Here, we will compare the time it takes to calculate the squares of 10 million integers numbered from 1 to 10 million. This code cell creates a simple Python list with the squares of the 10 million elements. We use the range function to generate the numbers. In the next code cell, we will perform the same operation but on a NumPy array. Here, we use the arrange function to create these numbers. Go ahead and run these code cells to look at the time it takes to perform these operations on the native list and on the NumPy array. Now that we understand that NumPy does provide faster primitives to work with numerical data, let's move on and learn the different functionalities available in NumPy. Let's start with creating multidimensional arrays. As we have seen above, while creating a simple array, we input a list. Let's start with creating multidimensional arrays. As we have seen above, while creating a simple array, we pass in a list. It's the same event for creating a multidimensional array, but here we will nest each dimension within that list. Let's look at an example below. Here we pass in a list which has 3 elements, and each of these elements have 4 elements. Thus, the dimension of this array will be 3 by 4, that is 3 rows and 4 columns. Run this code cell to print out the NumPy array we just created. Now look at the next code cell. This provides some useful methods that will tell you about the dimensions of the array and its shape. Go ahead and run them to look at the results. The next code cell gives you another example. Run this code cell to understand more on how to create multidimensional arrays in NumPy. NumPy also has some routines for creating various kinds of structured matrices, which are similar to those found in MATLAB and Octave. NumPy.zeros gives you a zero matrix. Here we are creating a 3 by 4 matrix with all its elements as zeros. Similarly, NumPy.ones gives you a matrix with all its elements equal to 1. NumPy.I gives you an identity matrix. Since identity matrices are square matrices, you can input just one dimensional value. Here, we are creating a 3 by 3 identity matrix. Now, in this code cell, we are creating a diagonal matrix with elements 1, 2, and 3. Here, we don't have to mention the shape of a matrix as NumPy automatically detects the shape of this using the number of elements given in the input. Notice that the shape of the matrix is given as a tuple, while all the elements will be given as a list. You could also create an uninitialized array using numpy.empty. Now that you understand how to create arrays in NumPy, look at exercise 1. This exercise provides you with an identity matrix created in two different ways, which are found to be equal as per the assertion. But in fact, there is a subtle difference between the I matrix and the IU matrices created. Explain that difference over here. Once done, you can move on to the next lesson.